If the universe is a game, physics is the rule book. It's the study of matter, energy, space, and time. It tells us how the pieces move, how they interact, and what happens when they crash into each other. For thousands of years, humans looked at the sky and saw magic. Then we started measuring, we started testing, and we found patterns. In the next 20 minutes, we're going to travel from the dawn of classical mechanics to the weirdness of the quantum realm, and finally to the edge of the cosmos. We're going to build the map of physics, piece by piece. Buckle up.
We start in the 1600s with Isaac Newton. Before him, people thought objects moved because they wanted to. Newton changed the game with 3 laws that described the clockwork universe. Law 1, inertia. Objects are lazy. If it's moving, it keeps moving. If it's sitting still, it stays still, unless you push it. Law 2, F equals ma. Force equals mass times acceleration. This is perhaps the most famous equation in history before Einstein. It says that if you want to move something heavy, you need a lot of force. Law 3, action and reaction. You push the wall pushes back. This is why rockets work. They aren't pushing against the air, they are throwing gas down to push themselves up. Newton realized that the same force pulling an apple to the ground is the same force keeping the moon in orbit around Earth. He unified the heavens and the earth with gravity. For 200 years, this was it. We thought we had it all figured out. If you knew the position and speed of every particle in the universe, you could predict the future perfectly. Physics was deterministic. But we were missing the engine that drives it all.
In the 1800s, the Industrial Revolution needed better engines. This gave birth to thermodynamics. Here we meet the concept of energy. Energy is the currency of the universe. It comes in many forms: kinetic, movement; potential, height; thermal, heat; chemical, and more. The first law of thermodynamics is the law of conservation. Energy cannot be created or destroyed, only transferred. The energy in your breakfast becomes the energy that beats your heart. The total amount of energy in the universe is constant. But there's a catch: the second law. This is the most depressing law in physics. It introduces entropy. Entropy is a measure of disorder. The second law states that in a closed system, entropy always increases. Heat flows from hot to cold, never the other way around. Things break, they don't fix themselves. This gives time an arrow. It tells us the difference between the past, ordered, and the future, disordered. Eventually, all energy will spread out evenly, and the universe will experience heat death. But don't worry, that's trillions of years away. While people were building steam engines, others were playing with sparks and magnets. For a long time, we thought electricity, lightning, static, and magnetism, compasses, were separate things. Enter James Clerk Maxwell. In the 1860s, he combined them into electromagnetism. He proved that a moving electric charge creates a magnetic field, and a moving magnet creates an electric field. They induce each other. But his math revealed something shocking. These fields travel through space as waves, and when he calculated the speed of these waves, it matched a very specific number: 299,792,458 meters per second, the speed of light. Maxwell discovered that light is an electromagnetic wave. This opened the door to the entire spectrum: radio waves, microwaves, infrared, UV, X-rays, and gamma rays. They are all the same stuff as visible light, just different wavelengths. Physics was looking great. We had mechanics, thermodynamics, and electromagnetism. We were almost done. Lord Kelvin famously said, "There is nothing new to be discovered in physics now." He was wrong. 1905.
Albert Einstein drops the mic. There was a problem. Maxwell's math said the speed of light is constant, but Newton's math said speeds add up. If you run on a train, you are faster than the train. What happens if you run on a train moving at the speed of light? Einstein realized that if the speed of light never changes, then something else has to give: time and space. This is special relativity. It says that the faster you move through space, the slower you move through time. If you travel near the speed of light, you age slower than your twin back on Earth. Also, energy and mass are interchangeable. E equals mc squared. 10 years later, Einstein updated Newton's gravity with general relativity. He said gravity isn't a force pulling you down, it's a curvature. Matter tells spacetime how to curve, and spacetime tells matter how to move. Earth isn't being pulled by the sun, it's rolling along a straight line in curved space. Relativity rules the world of the very big and the very fast. But when physicists looked at the very small, atoms and subatomic particles, Einstein's rules fell apart. Relativity didn't work here. Welcome to quantum mechanics. In the 1920s, scientists like Bohr, Heisenberg, and Schrödinger discovered that the subatomic world is insane. 1. Quantization. Energy isn't continuous like a ramp. It's chunky like stairs. These chunks are called quanta. 2. Wave-particle duality. Is light a particle or a wave? The answer is yes. Matter acts like a particle when you look at it and a wave when you don't. 3. The uncertainty principle. You cannot know a particle's position and speed at the same time. The more you know one, the less you know the other. The universe at this scale isn't precise. It's probabilistic. It's a roll of the dice. 4. Superposition. Until you measure a particle, it exists in all possible states at once. This famously annoyed Einstein, who said, "God does not play dice," but experiments show he does. Quantum mechanics is the most tested theory in history. Without it, you wouldn't have computers, lasers, or the internet.
So where are we now? We have combined quantum mechanics into the standard model of particle physics. This is the Lego set of the universe. It says everything is made of 12 matter particles, like quarks and electrons, and held together by 4 forces: gravity, electromagnetism, strong nuclear, weak nuclear. We've used this to look back 13.8 billion years to the Big Bang. We know the universe is expanding and it's accelerating. But here is the humble pie. When we calculate how much gravity exists in the universe, there isn't enough visible matter to explain it. Galaxies spin too fast. They should fly apart. So we realized that 95% of the universe is invisible to us. 27% is dark matter, stuff that has gravity but we can't see. 68% is dark energy, a mysterious force pushing the universe apart. The stuff we know, stars, planets, you, me, this video, is only 5% of reality. Physics is the story of unification. Newton united the heavens and earth. Maxwell united electricity and magnetism. Einstein united space and time. But we have one final crack in the map. General relativity, the big stuff, and quantum mechanics, the small stuff, mathematically hate each other. They don't fit together. The holy grail of physics is a theory of everything: quantum gravity. String theory? Loop quantum gravity? We don't know yet. And that is the beauty of physics. We have mapped so much in 20 minutes, from the atom to the Big Bang. But the map has blank spots. The game isn't over. And the next great discovery could come from anyone, maybe even you. Thanks for watching.